Uh, yes, ambient pet bar. So, what is ambient? Does anybody can bring up the definition? Has anybody heard about ambience? Ambience.
Atmosphere within a situation.
Yes, yes. We could find it in music. Philips came up with ambient intelligence. We can also find it in art. So it's something that kind of describes the atmosphere, or actually introduces the atmosphere without human interaction. So I was thinking something about like running stairs. You are approaching the running stairs and they are starting to running in just independently of what you do. So that's what we understood under ambience. But we first climbed ambient pet bar, and then we found out that there is no term ambient architecture, and we wanted to teach it. So that was the first conflict, and we had to convince the students that we must actually find the definition of ambient architecture, what it actually is, if it's even possible to make something like that. Is it interaction? Is it moving? Is it interacting with lights? So I will get to this after a few slides, what we found. So we introduced a course which had only 1 month, so 6 weeks, 5 weeks, 5 weeks. And we introduced to the students unknown material, which was a new developed patented plastic brick made of recycled bottles, and unknown behavior, which was ambient. And then in these 5 weeks we wanted the students to combine this and come up with some installations or architecture. So a few words about the brick. We are trying to kind of reuse bottles in terms of that we came with a new shape which is combinable together. And you can build a certain type of architectures, inner installations, pieces of dividing walls, etc. The advantage of such a building material is that it's empty and it's closable, which means that it's a space that you can put some technology in. Ambience means that you can't see your technology. The technology is hidden somewhere in the architecture, and it reacts on your presence or on some pre-programming, but it's incorporated within these pieces of architecture. So we perceive this as a precedent of some kind of intelligent brick, which can be fulfilled with some intelligent material or technology. And together with that, so easy peasy, kids work. You can build walls, whatever you want to do, very easy. We could incorporate technologies, Wi-Fi, regulated lightings in it, and we could all of this fit into one brick, which was used in the Expo Milano, where we really tried to make people first sit on it and use it as chairs, and to regulate the lighting, to play around with the bricks, either with their phones or just manually. So the brick was tested. It was 5 months, and none of it broke. So we thought, okay, it's working. It can bear load. It can carry 1.5 tons. So we can start building with such a brick. We also introduced an application which people could choose the bricks and manipulate their color and play games to like obsess as many bricks as they wanted. But this was still some kind of interaction, really playing around with inserting technology into these units. So then we came with the solutions. What is ambience? So we found out that Philips already invested 3.7 billion euro into the research of ambience. So they really want to have our homes. It was really focused on homes, where they also introduced Home Lab, where they really observed people, how they behave at home, in order to really accommodate the technology on the behavior of the real inhabitants. So we thought, okay, it's worth that we bring students to this terminology and make them try to really create ambient architecture. This was our kind of vision, that they will build a bar, and the bar will react on them in terms of what they invented. The other thing was that we had students of technical university and students of non-technical branches of media, new media, and the difference was that the students from technical university, they really had very concrete ideas how the architecture could interact with the users in terms of like reacting on the distance or on touch. Or one very funny thing was that they wanted to distinguish between men and women, so that the bar will react with a different color if man stands by it, or a woman, or that it makes some noise together. So, but this was not realized because nobody could actually detect a man from a woman. So, any ideas how you can really, by some sensors, find out if there is a woman standing or a man? It's really hard in the end, because you can't do it on the load, you can't do it on the height, even length of the hair. It's really, then we were thinking about some percentage, that there will be a screen showing, okay, you are 70% of men and then 30% of women, or something like that. But nevertheless, we ended up with some measurement of weight of alcohol on the bars, that if you placed beer with half kilo, then it would have a different color from a really small amount of strong alcohol. So that was one of the interactions. The other was that we had some kind of gate where people were measured how many people trespassed the door to the bar, and then the bar reacted on it. So what I wanted to say, that we were actually hired to decorate an event with these installations. It was the student night with very big event for 5,000 people. It was it was in the faculty of mechanical engineering, so in the halls. And they also took the break as a symbol of that event, so it should have been there everywhere. So I chose very few examples of what students did. What I wanted to say also to this, that students have many times really megalomaniac ideas about how it can react. And when they get to the sensors, they are not able to put it together, because the sensors are really tiny, then their structures are really big, and to accurate the sensor so that it reacts on the small weights, or to do it in fact, is really a bigger task than they can manage within a certain time lapse. So we didn't have so much time for it. It was just really 1-2 times a week and a very quick event. So the time investment into that they can even imagine how to program such lights, because each light was one program dot, and we had to cooperate with students of electrotechnical engineering who could program really the lights according to the ideas of the architects. So that was really inter-domain collaboration. And we had to also have electrical engineers to connect Arduinos. It was regulated by Arduinos to the installations, and then the only thing architects were able to do is to draw the schemes of the dots. Where should they be? So in the end, ideas or the designs were not that far from the reality. Sometimes they really had to find out actually how to tell the programmer what the installation should do. So they did it through GIFs, through movies. It was really a kind of challenge how to tell the programmer what shall they do, because the transmission between like the ideas in the head and then the real programming was a little bit of gap. So I have a short video of all the installations, because in the end there were 15 installations in the site, and what we learned from this lecture is that really the very intensive course is the best way how to teach these subjects. If you want to have like from idea to a real exhibition, then if it's just once a week, we also posted a questionnaire to the students. What did they acknowledge on the course most? And then the intensive and speed course was the most rated actually into this. So we not only worked with real battles, but we worked also with the pet bricks. And the message of the whole event should have been also like that reuse is one of the most important thing. So we had 3 programmers, electricians, and 42 students, which was really kind of big amount. So they really tried to investigate all possible variations, how to do architecture from bottles or even plastics, and to show its reuse. It was like the reuse support, and they went really very diverse directions into it. Oops. All students like about it. So this was like a course which was not exhibited anywhere. It was just the event, and the exhibition took exactly 8 hours, because it was like a big party with music, and for many students it was for the first time that they really tried even to realize their designs, that they really tried to convert the ideas into the reality. So they were also fighting with the amount of the material, and they found out that in reality it's really big. The pictures are very easy to do, and then when it comes to transportation, so all the installation has to be demountable and reassemblable again, and movable and very flexible. Yes. If you don't have a question.
Thank you very much.
Yeah, this is like a